Hello, AS Physics students. Welcome back to the channel. In this video, I am going to discuss Cambridge International AS Level Physics Paper 1 Multiple Choice. The paper that I'm going to discuss is May June 2025, Paper 1-4. Are you ready? Let us get started. Now, let us start with the first question. The number of atoms in a mobile phone handset may be estimated by dividing the approximate volume of the handset by the approximate volume of an atom. Right, so what is a reasonable estimate of the number of atoms in a mobile phone handset? So I'm going to find the volume of the handset first. So which is equal to the length of the handset multiplied by the width multiplied by the thickness of the handset. So I'm going to just estimate the length of the handset maybe 15 cm. The width of the handset may be 7 cm and the thickness of the handset may be 1 cm because the mobile phones nowadays are super duper thin. So I'm going to convert to meters. So this is 0.15 times 0.07 times 0.01 meter. And I got 1.05 times 10 to the power negative 4 meter cube. That is the volume of my handset. Now, estimate approximate volume of an atom. I know that the atom in the handset, because they are solid, the distance from the center of one atom to the center of the next atom is about 1 times 10 to the power negative 10 meter. And then this is like a diameter of one atom. So I want to find the radius of one atom, which is 0.5 times 10 to the power negative 10 meter, because I just take diameter divided by 2. And based on the kinetic theory of gases, okay, because we want to simplify our calculation, that is why I assume that the atom is like a perfect sphere, a small sphere. So that is why I find the volume of a sphere 4 over 3 pi r cubed. So this is equal to 4 over 3 pi 0.5 times 10 to the power negative 10, but you have to cube it. And here I got 5.24 times 10 to the power of negative 31 meter cube. Now I can estimate the number of atoms. I just take the volume of the mobile phone divided by meter cube divided by the volume of an atom, 5.24 times 10 to the power negative 31 meter cube, and I got about 2 times 10 to the power of 26. So B is the correct estimation. Number 2, which unit is not equivalent to the unit of energy? Bear in mind, energy overall, it is being defined as ability to do work. Now, first one, Newton times meter. It is like the product of force and distance. This is the unit of work. And the unit of work, because work is equivalent to energy, this is, yes, the unit of energy as well. Volt coulomb. Now, I define my potential difference is being defined as work done divided by charge. Work, that is also energy. So I would say energy is equal to VQ. V is measured in volt. Charge is measured in coulomb. So B is also correct. C, watt second. So remember, power is equal to energy over time. That is why energy is equal to power times time. Power is measured in watt and time is measured in second. This is also a unit of energy. Kilogram meter per second, that is the unit of force, right? Kilogram meter per second. This has nothing to do with energy, so D is not a unit, equivalent unit of energy. Number 3, calipers are used to determine the thickness of the wall of a glass tube. Following measurements are made. Internal diameter of the cube is 10 plus minus 0.1 mm. External diameter of the tube is 12 plus minus 0.1 mm. What is the thickness of the wall of the tube? So this is called the thickness. If I find the difference between external diameter and internal diameter, I will get two thicknesses of the tube. So that is why the different two thicknesses of the tube is equal to 12 minus 10, which is equal to 2 mm. I only want one thickness of the wall. So that is why I take 2 divided by 2. That is equal to 1 mm. Now, When an absolute uncertainty is given, right, you just find your delta t. When you deal with subtraction, you have to add up the absolute uncertainty. So I get 0.2 mm. That is for two thicknesses. So I only want one thickness. So that is why I take delta t divided by 2. I get 0.1 mm. So the answer is A. Number 4, the diagram shows two fixed points, two fixed pins, Y and Z. A length of elastic is stretched between Y and Z and around the pin X, which is attached to a trolley. And then X is at the center of the elastic and the trolley is to be propelled in the direction of P. This is where, okay, force is being applied. P at right angles to YZ, the tension in the elastic, okay, this is a tension. It is equal to 4 Newton. And what is the force accelerating the trolley in the direction of P when the trolley is released? Now, I try to simplify this calculation. I put theta here because I have all the lengths given. Length of the string is given. I just want to find my sine theta so that I can compare with the force. Sine theta here, the length is 30 cm. It is given 30 mm. So I'm just going to put 30 divided by 50. Sine opposite over hypotenuse. This is 90 degrees. So my theta is equal to shift sine 30 over 50. And I got 37 degrees. Now, I use back the Pythagoras theorem. Sine theta is equal to force over tension. This is 2 times the tension because this is the whole tension of the string. So force is equal to 2 times the tension sine theta. So I got 2 times tension times 4 sine 37. The answer is 4.8 Newton. C is the answer. Now, number 5, a student cycles uphill from home to a shop, taking 10 minutes. The student then spends 5 minutes in the shop before cycling home downhill at twice the initial speed. Which graph could show the variation with time, the distance traveled by the student? Now, you bear in mind, distance is a scalar quantity. Right, now let me see. Travel up the hill to a shop, which takes about 5 minutes going up the hill. So the distance must be increasing within that 10 minutes. So this is increasing until 5 minutes. This is wrong. This is increasing until 10 minutes. This is correct. This is until 5 minutes. This is wrong. D until 10 minutes. This is correct. Now, stop for 5 minutes. Okay, not moving. Distance maintain the same for 5 minutes. This is 5 minutes. Yes, correct. This is also 5 minutes, which is correct as well. Now, the last part, okay, cycling downhill with twice the initial speed. So you have to find the initial speed first. Okay, I get 2 value here. This is 10, 1. This is 0, 0. I get my speed first, initial speed. 1 minus 0 over 10 minus 0. I get 0.1 meter per second. And then this is 15. 1, this is 20 and 0. So my final speed would be 1 minus 0 over 15 minus 20. I get 1 over 5, which is negative 1 over 5, which is negative 0.2 meter per second. Okay, don't bother first. Here, I look at the two value. This is 10 and 1. This is 0 and 0 and 0. Initial speed will be 1 minus 0 over 10 minus 0. I still get 0.1 meter per second. And the final speed, this is 15 and 1. This is 20 and 2. Now, final speed, 2 minus 1 divided by 20 minus 15. So I get 1 over 5, which is 0.2 meter. Kilometer, not meter per second, kilometer per minute. Right? Okay, the unit is not meter per second, kilometer per minute. Okay, I just going to put it correctly right here. Okay. Okay, now I just going to put here as 0.2 first, kilometer per minute. Now I compare the value. One is in negative, the other one is positive. But you have to remember, this is a graph of distance traveled by the students. Distance is going to be increasing. right? Because distance is a scalar quantity, so you add up all the numbers that involve. So if you put in negative, that is called displacement, right? So that is why the best answer is D. Number 6, a ball is released from rest. I am going to put this U equal to 0 from a window at a height of 12 meter above the ground. Air resistance is negligible. What is the time taken after release for the ball to reach the ground? I am going to use one of the kinematics equation S equal to UT plus half GT squared, because when you release, the ball will fall with gravitational acceleration due to air resistance, which is being negligible. So the height is 12, and then the whole thing here is equal to 0. Why? Because my initial speed of the ball is equal to 0. So half 9.81, and then I need to find the time taken, t squared. So t is equal to 12 times 2 divided by 9.81, and then you just square root your answer, and you get 1.56 seconds or 1.6 seconds. C is the answer. Number 7, which word equation is not correct? Force is equal to change in momentum. This is wrong. Change in momentum, impulse is equal to the change in momentum. Force is mass times acceleration. This is true. Force is equal to moment divided by perpendicular distance from the pivot. Yes, because moment is equal to force multiplies by perpendicular distance from the pivot. This is correct. Force is equal to work done over displacement in the direction of the force. This is true because work done is defined as product of force and displacement move in the direction of force. This is true. So the answer is A. Number 8. A skydiver is falling vertically with terminal velocity when the parachute opens fully. Which statement describes the motion of the skydiver for the first few seconds after the parachute opens fully? So falling with terminal velocity, that means air resistance cannot be ignored. So falling with non-uniform acceleration, yeah, with when the terminal velocity is a few seconds after the parachute is open. So when the parachute is open, right? So what happened to the speed? A large air resistance acting on the skydiver, because initially terminal speed means a constant speed, right? The skydiver already fall with a constant speed, but when the parachute is open, due to the large surface area of the parachute, right, a large amount of air resistance acting on the skydiver together with the parachute. Right. So what happened to it? So it will be like floating a bit and then fall down even slowly. So falling with non-uniform acceleration with decreasing speed when the skydiver opens the parachute. B is the answer. Now, number 9, two gliders are traveling towards each other on a horizontal air track. Glider P has a mass of 0.3 kilogram and is moving with a constant speed of 1.2 meter per second. Glider Q has a mass of 0.6 kilogram and is moving with a constant speed of 1.8 meter per second. The glider has perfectly elastic collision. What are the speeds of the two gliders after the collision? I want to teach you one way which you do not require any complicated calculations. Right. When you see the word perfectly elastic collision, that also means that the relative speed of approaching must be equal to the relative speed of separation. So we find the relative speed of approaching. How do you do that? I teach you the easiest way. When you see that the two gliders are moving at opposite direction, you just add out their speed. So the relative speed of approaching is equal to 1.2 plus 1.8, which is equal to 3.0 meter per second. And okay, relative speed of the separation must be the same as well. You need to get 3. So I add 1.2 plus 0.6. I only get 1.8 meter per second. This is wrong. Right, 2 plus 1.4. I get 3.4 meter per second. I want 3. 2.8 plus 0.2. Wow, I get 3 meter per second. And 3.6, okay, if I want to get 3, maybe I minus, right? Or I add 2 gliders after the collision. Oh, this is 3.6 plus 0.6. I get 4.2, not possible. If I get 3.6 minus 0.6, I get 3.0 as well. This could be the answer. So when you see there's you can minus the speed or you can add the speed, depending, because the question did not mention that what happens to these gliders, whether they are moving in the same direction or in the opposite direction. So as long as the trolley or the gliders are moving in the opposite direction, if you want to find the relative speed, right, you just add them up. If they add in the same direction, you have to find the difference between the two speeds. Right. Now, since it seems like I have two answers here, I have no choice but to use the kinetic energy. So I need to find the initial kinetic energy and I need to compare with the final kinetic energy. Then only I can be sure which is the answer. So the initial kinetic energy, the total initial kinetic energy is half mass 0.3, 1.2 square plus half 0.6 and 1.8 square. Add this up. 1.2 square times 0.3 times half. I got 0.216 plus 1.8 square times 0.6 times 1 over 2. That is 0.972 plus 0.216. So my total initial kinetic energy is 1.19 joules. And I calculate the kinetic energy of C and of D. So of C is here. I'm going to do here. Half the mass of glider P is 0.3. And this is 2.8. I square it. Plus half mass of the glider Q is 0.6 times 0.2. I square it. So 2.8 square times 0.3 times half, I got 1.176 plus 0.2, I square it, and then I times 0.6 times half, I get 0.012. So I add 1.176 and I got 1.19 joules. And I just wanted to prove that D is wrong. Half the mass of P is 0.3 and 3.6 square plus half 0.6 and times 0.6 square. 3.6 you square it times 0.3 times half. I got 1.94 plus 0.6 square times 0.6 times half. I got 0.108. 1.94, you could see that this is 2.05 joules. This is not possible. D is not possible. One of the conditions or the situation which must be fulfilled for perfectly elastic collision is that the total initial kinetic energy must be equal to the total final kinetic energy. So C is the answer. Number 10, which statement about the couple is correct? Couple produces pure turning effect. Remember that. So A, it acts to produce a translational, no translational, only rotation, no translational. So B is the answer. Number 11, a picture frame hangs from a string. The string is supported by a pin. The frame is in equilibrium. Which diagram shows the vector triangle of forces acting on the picture frame? Weight of the picture frame must be acting downwards, supported by the two tensions, right, of the string. Weight here, it seems that the weight is acting outwards. This is wrong. Weight must be acting downwards. Okay, if you want it to be easier, you know that all the forces are in equilibrium, right? It has to follow, like you form a closed triangle, right? The direction follow each other. Could you see that? This direction, I draw down first, and then I draw up, follow each other, and I form a closed loop. So that is why D is the answer. Look at why C is not the answer. Because I draw down here. How am I going up? Because another arrow is coming here to oppose me. That is not equilibrium. D is the answer. Number 12, a solid metal cuboid of density 2,700 kilogram per meter cube has sides of length 1 meter, 2 meter, and 4 meter. The cuboid can be placed in a horizontal surface so that it rests on any one of its 6 faces. What is the largest pressure that the cuboid can exert on the surface due to its weight when it rests on one of its 6 faces? Okay, what is the largest pressure? Pressure is being defined as force over area. I want the largest pressure. The area of contact must be the smallest. Now, density is given. I'm going to use the force as mg over smallest area. I have to bear that in mind. And density of the cuboid is given. Density is mass over volume. I want to find the mass, so I just take pressure, density times volume, g over area. Now I'm going to use this equation to find the pressure. So my pressure would be equal to density is 2,700. Volume of the cuboid, the smallest volume, I would say 1 times 2. Okay, volume of contact. Okay, 1 times 2 times 4, right? This is the volume of the contact, which is the smallest one. So you put it there. So the smallest volume is 1 times 2 times 4. And then G is 9.81 over this is the smallest volume of contact. So this is the height, right? Okay, not this one. And then over the smallest surface area. Smallest surface area is 1 times 2. So I multiply everything. I got 105.9 times 10 to the power of 3 Pascal. So that is why I round it off to 110 kilopascal. D is the answer. Number 13, a cylindrical iceberg of height h floats in seawater. The top of the iceberg is at a height h above the surface of the water. Density of the ice is rho I and density of the seawater is rho W. What is the height h of the iceberg above the seawater? Now, I want to say that I'm using the floating force, right? I would say that the volume, the weight of the water being displaced must be equal to the weight of the iceberg because the iceberg is placed in the sea water. Now, weight of water displaced due to the iceberg being placed in the sea water is equal to the weight of iceberg. Weight of the water, weight is mg, right? That is water is equal to weight of the iceberg, mg, ice. Now, I'm going to use density is equal to mass over volume. Mass is density of the water, volume of the water times g, equal to density of the ice, volume of the ice times g. Now, I want to cancel the g first. G and g cancel off. Volume, density of the water times the volume of the water. Volume, I would put area. I put pi r square because area of the ice cube, I assume it to be circular. And then the height. So the height of the water being displaced is h minus h equal to density of the ice. Volume of the ice, pi r square times the height, which is capital H, the total height of the iceberg. Now, pi r square and pi r square, I think we can cancel off this. Pi r square, pi r square. So I have density of the water H minus density of the water small little h is equal to density of the ice times H. Wow, okay. And then I put density of the water H minus density of the ice H is equal to density of the water times H. Factorize out the H, I have density of the water minus density of the ice equal to density of the water H. I'm supposed to find the small little h. So H is equal to H density of water minus density of ice over density of the water. So that is why H is H times density of the water divided by density of the water, that is 1 minus density of the ice divided by density of the water. Right, so H is equal to capital H, 1 minus density of ice divided by density of the water. A is the answer. Number 14. In which situation is work done on an object? Now, A, the object slides with a constant velocity along a horizontal frictionless surface in the vacuum. There is no work done, right? Because it's like with a constant velocity, there's no force being applied to the object to cause a displacement. B, a person holds the object at arm's length at a fixed height above the ground. There is no change in height, so no work is done. C, a person pushes the object up on a frictionless ramp. Push the object up, going up. So the object is gaining gravitational potential energy due to the pushing force plus the distance of the object. Yes, this is doing work on an object. D, the stationary object floats partially submerged in the water, just like your iceberg. It is stationary, submerged in the water, so no work is done on it because the forces are balanced. Number 15, an electric motor operating a leaf has an output power of 20 kilowatt. The leaf and passengers have a combined mass of 1,500 kilogram. The motor races the leaf at constant speed through a distance of 20 meter. How long does it take? So when you see the word constant speed and the power is being given, always use this. Power is the force multiplied by the constant speed. Right, power is equal to 20 kilo. I times 10 to the power 3. And the force, okay, because it is lifting the object up, so the force must be the weight of the object, mg. Now, V, because the object, the whole system, the motor is moving at constant speed. That is why you can use your speed is equal to distance over time. Right, so 20 times 10 to the power of 3, mass is 1,500, g is 9.8, distance is 20 meter divided by time. Time is equal to 1500 times 9.81 times 20 divided by 20 times 10 to the power of 3. So the time taken is 14.7 seconds, which you round it off to 15 seconds. B is the answer. Number 16, in which situation is the least amount of energy transferred? So you have to compare A, B, C, D. I'm going to do for A first. A student and a motorcycle of total mass come to rest from a speed of 2 meter per second. So I'm going to find the kinetic energy. Right, so the kinetic energy is equal to half mv square. Initial kinetic energy is 80 times 2 square, and I got 160 joules. B, a student of mass 50 kilogram falls a vertical distance of 2 meter. So the energy is gravitational potential energy, which is equal to mgh. 50 times 9.81 times 2, and I got 981 joules. C, a student pushes a car with a horizontal force of 70 Newton for a horizontal distance of 2 meter. Energy is ability to do work, so you can find work. Force multiplies by the distance moved. right? So 70 times 2, so I get 140 joules. And D, a student switches a 70-watt lamp for 20 seconds. Energy is equal to power times time. 70 multiplies by 20, you get 1,400 joules. I want the least. So C is the answer. 140 joules is the least. Number 17, what is the definition of strain? Strain is being defined as extension per original length. This is the symbol of strain, extension over original length. Number 18, a spring of unstretched length 0.1 meter is suspended vertically from a support. A weight of 2 Newton is attached to the bottom of a string and its length increases to 0.515 meter. And then after that, additional weight. Okay, so I would write about this spring first. 2 Newton, right? Yeah, additional weight after that added to the bottom of the spring. The spring obeys Hooke's law. How much extra elastic potential energy is being stored in the spring due to the addition of the 4 Newton weight? So from here, I am going to find the spring constant first. F equals to kx. F is given as 2 Newton. Spring constant. Extension is 0.15 minus 0.1. From here, my spring constant is 2 divided by 0.05, which gives me 40 Newton per meter. And then from here, I want to find my elastic potential energy due to this 2 Newton weight. So I'm going to use half kx squared. Half k is 40, extension is 0.05. I square it and I got, let's do it. I got 0.05 joules initially. After that, you look at the red color that I added. I added, okay, with another mass, which is 4 Newton added. So the total weight will be 6 Newton. Remember that. Now I find the new elastic potential energy. Right. If I want to find a new elastic potential energy, I don't have the extension. Never mind, I have another equation for elastic potential energy, which is half Fx. Right. And then additional weight, how much? Oh, I don't have the value. Okay, never mind. I can find my extension. How do I find my extension? Okay. I am using back the Hooke's law. I know this is the same spring that I'm using. So I'm using the Hooke's law. F equals to kx. I want to find my extension. So the force now would be 6 Newton. Spring constant 40 and I find my extension. So the extension is 6 divided by 40. So 6 divided by 40 and I got 0.15 meter. Then final elastic potential energy half. Okay, if I want to use kx squared, it's also okay, but I try to use fx, not a problem. You will end up getting the same answer. But the force is 6, extension is 0.15. So I got 0.45 joules. Extra EPE would be 0.45 joules minus 0.05 joules. And I got 0.40 joules. D is the answer. Question number 19. Two progressive waves meet at a fixed point P. Variation with time of the displacement of each wave at point P is shown in the graph. What is the phase difference between two waves at point P? First of all, this is the equation of the phase difference. It is measured in degrees, so I divide 360 degrees equal to x-axis is time, so you have to find the time difference divided by 1 period. Right, the period of the wave is, start from here. You can determine from either of the wave. They have the same period. One full cycle. This is period. Period is given as 0.8. Now, our job is to find the time difference. So how to find the time difference? I need to compare between the two waves. Now, I draw the yellow wave first. Right. If I want to compare, I need to make a fair comparison. So I start, okay, the blue wave. I look at this blue wave. Okay, I draw out two different waves here. And then the other one is my yellow wave. So I want you to see this carefully. If I want to compare, I don't want to compare from this point because I don't know what is the time of displacement of this yellow wave. If I want to compare, I compare, maybe I start from here of the yellow wave and I compare with the blue wave. Right. So when I start from here, okay, 0 point of the yellow wave and 0 point, I assume it to be 0 point of the blue wave. Right? So you could see that this yellow wave is been leading because it comes first. Right? By what is the difference between these two waves? So you take 0 0.8 minus 0 0.5. So the time difference is 0 0.3 seconds. Right, so you just put phi over 360 degree over is equal to 0 0.3 over period 0 0.8. Phi is equal to 0 0.3 times 360 degrees or divided by 0 0.8. So 0 0.3 times 360 degrees divided by 180 and you get 0 0.3 times 360 divided by 0 0.8, not 180. So I get 135 degrees. So the answer is C. Number 20, a microphone is connected to a cathode ray oscilloscope CRO. Diagram shows the waveform on the display of the CRO when the microphone detects a sound. The Y gain is set to 1 volt per division. Time base is set to 2 milliseconds per division. Which row gives the amplitude and the frequency of the waveform? So you want to find the amplitude, you have to draw your equilibrium position or fixed position. Because after all, amplitude is the maximum displacement from equilibrium position. So if I want to find my amplitude, how many divisions involved? 1, 2, 3. So amplitude is equal to 3 division multiplied by Y gain, 1 volt per division. So amplitude is 3 volt, either A or B. Now, before I find the frequency, I need to find the period first. Period, okay, how do I find the period? I calculate this is the number of one complete oscillation. That is one period. How many division involved? Look at x-axis. 2 division. So period is equal to 2 division times the time base, 2 millisecond per division. So period is equal to 4 millisecond. Frequency is 1 divided by period, 1 divided by 4 millisecond. And you get 250 hertz. B is the answer. 21, a progressive longitudinal wave is traveling horizontally from left to right. A graphical representation of the wave at one instant in time is shown. Which row could give the correct labels for your x-axis and y-axis of this graph? The x-axis, okay, y-axis it has to be displacement of the particles, cannot be upwards or downwards because that's transverse wave. Right, so if this is displacement of the particles to the right and x-axis because the wave is traveling towards left, from left to right. So I would choose distance. So A is the answer. Now, number 22, a vehicle moving with a speed of 30 meters per second directly towards a stationary observer. The horn of the vehicle emits sound of frequency 440 Hz. The speed of the sound in air is 340 meters per second. What is the frequency of the sound heard by the observer? This is Doppler effect. Now, F naught is equal to Fs, frequency of the source, times the speed of the sound in air, divided by, because this vehicle is moving towards the observer, so V minus V of the source. Now, frequency of the source is 440, and then the speed of sound in air, 340. Speed of the sound in air minus the speed of the sound of the vehicle. So when you solve it, you should get 482.6 hertz. You round it off to 483 hertz. D is the answer. Number 23, which role could describe the electromagnetic wave? Electromagnetic wave are transverse wave, and then it is this travel in this free space means it is in vacuum. So the speed in vacuum is the same for all the wavelengths. D is the answer. Number 24, a horizontal beam of light is incident normally on a polarizing filter. Incident light is vertically polarized and has an intensity of 24 watt per meter square. The direction of the transmission axis of the filter is at an angle of 30 degrees to the vertical. What is the intensity of the light in the transmitted beam? So you can use I is equal to I naught cos square theta. So incident intensity or initial intensity, 24 cos square 30 degrees. So your answer should be 18 watt per meter square. A is the answer. Number 25, a pipe of length 100 cm is open at both ends. A loudspeaker situated at one end of the pipe can emit sound of different wavelengths. Which wavelength can produce a stationary wave in the pipe? Now, when the pipe is open at both ends, remember, both ends must be antinodes. So I need to find, okay, the initial, okay, fundamental frequency first of this wavelength. This is the length of the wavelength, 100 cm. Yeah, it is given. Now, no problem with that. So I can produce two antinodes first here. This is 1 over 4 lambda. This is also 1 over 4 lambda. So I end up getting 1 over 2 lambda is equal to 100 cm. Lambda is equal to 200 cm. But I don't have the answer of 200 cm. Never mind. I will just redraw it. Okay. Now, the next wavelength, okay, because I need to remember the rule. The rule is that the open ends must be antinodes. So I create another one, maybe this one and this one. So this is 1 over 4 lambda, this is 1 over 2 lambda, this is 1 over 4 lambda. 1 over 4 plus 1 over 2 plus 1 over 4, that is equal to lambda equal to 100 cm. But I don't have lambda equal to 100 cm. Never mind, I keep on increasing, okay? Okay, the number of wavelengths inside the tube. So maybe the next one could be like this. Okay, I just try. So this is 1 over 2 lambda, 1 over 2 lambda, 1 over 4 lambda, 1 over 4 lambda. 1, 2, 3. So 3 over 2. 1, 2, 3 over 2 lambda. Because this is 1 over 2 is equal to 100 cm. Lambda is equal to 100 times 2 divided by 3. Let me see. 200 divided by 3. I don't think I have the answer as well. 66.7 meter. I don't have the answer as well. Okay, never mind. I just increase more and more lambda inside the stationary, inside the pipe. So I need to use maybe 1, 2, and then the next one is like this. Okay, so this is 1 over 4 lambda, 1 over 2 lambda, 1 over 2 lambda, 1 over 2 lambda, and 1 over 4 lambda. 1, 2, 3, and 4 over 2 lambda is equal to 100 cm. Lambda is 100 times 2 divided by 4. 200 divided by 4, I get 50 cm. Wow, I got the answer. A is the answer. So I try an error. Number 26, a student makes a sound at point R near a building. A second student standing at point S around the corner of the building. You see the word? Corner of the building hears the sound. The building is a solid structure and there are no other structures nearby. Which effect best explain how the student at point S is able to hear the student at point R? This effect is called diffraction, spreading of waves. Now, number 27, red light of single wavelength from a laser is incident on the double slit. A pattern of interference fringes is observed on a flat screen that is placed parallel to the double slit. Which change increases the separation of the interference fringes on the screen? Do you recall the interference equation? Lambda is equal to AX over D. Lambda is the wavelength, A is the slit separations, X is the fringe separation, and D is the distance between the double slit to the screen. Now, X as the subject, lambda D over A. I want to increase the separation of the fringes, so I have to increase the wavelength, or I increase the distance between the double slit and the screen, or I decreases the slit separation. Right, now decrease the distance, double slit to the screen. No, I want it to be increased in order for me to increase the separation between the fringes. Decreases the separation of the slit. This is correct. Replace the red light with blue light. You are decreasing the wavelength. No. Replacing the red light with green light. You are decreasing the wavelength. No. So B is the answer. Number 28, an electromagnetic wave is incident normally on a diffraction grating. A second order is produced at an angle of 30 degrees to the direction of incident light. The grating has 500 lines per cm. What is the wavelength of the wave? Do you recall the equation of the diffraction grating? D psi theta is equal to n lambda. D is the grating spacing, but the grating spacing is not given. So you can replace it with 1 over n. N represents the number of lines per meter. So psi, this is second order, theta 2 is equal to 2 lambda. 1 over 5,000 lines per cm. You have to divide, right? You have to convert that cm to meter. Psi 30 degrees is equal to 2 lambda. So lambda must be equal to 5 times 10 to the power negative 7 meter. B is the answer. 29, the resistance of a lamp 10 ohm and the potential difference across it is 6 volt. How many electrons pass through the lamp at the time of 24 hours? Now I'm going to use Ohm's law to find the current first. Current is equal to V over R. V is 6 divided by 10, so the current is 0.6 ampere. And current is defined as rate of flow of charge. And, okay, I find the charge first, current times time. So the current is 0.6 and the time is 24 hours. You have to convert to second. Times 60 times 60. Now 0.6 times 24 times 3,600, and I'm just going to write it all, 51840 coulomb. Total charge is also depending on the number of electrons that flow in the lamp times the charge of one electron. So 51840 is equal to number of electrons times the charge of electron is 1.6 times 10 to the power negative 19. So that is why n is 51840 divided by 1.6 times 10 to the power negative 19. So divided by 1.6 times 10 to the power negative 19, and you shall get 3.24 times 10 to the power of 23. The answer is D. 30, what is equivalent to 1 volt? 1 volt, V is being defined as work done per charge. Work is measured in joules, charge is coulomb. So B is the answer. 31, the resistance of some electrical components may change with changing conditions. Which component's resistance increases? A filament lamp, as the potential difference across it increases. This is true. The resistance of the filament lamp would increase due to PD across it is increasing. Now let us check B. LDR has an intensity of light incident on it increases. When the intensity or the brightness of the light shine on the LDR increases, the resistance of the LDR would have to decrease. This is wrong. C, a metallic conductor at constant temperature as the current through it is increasing. So it would not increase the resistance due to the temperature of the conductor is constant. Resistance would be constant. Thermistor, as its temperature increases. When the temperature increases, the resistance of the thermistor would have to decrease. So this is also wrong. Number 32, gold is sometimes used to make very small connecting wires in electronic circuits. A particular gold wire has length 2.5 times 10 to the power negative 3 meter, cross-sectional area 6.25 times 10 to the power negative 8 meter square. Gold has resistivity of 2.3 times 10 to the power negative 8 ohm meter. What is the resistance of the wire? So I put resistance is resistivity times length divided by cross-sectional area. So resistivity is 2.3 times 10 to the power 8, negative 8, length 2.5 times 10 to the power negative 3, and the area, cross-sectional area is 6.25 times 10 to the power negative 8. So the resistance is 9.2 times 10 to the power of negative 4 ohm. C is the answer. 33. A cell of constant electromotive force, EMF, and negligible internal resistance is separately connected into 4 different circuits. In which circuit does the power dissipated by the lamp stays the same as the variable resistor is adjusted? I would say that you look at A, lamp and variable resistor are connected in parallel. So even though the variable resistor is being adjusted because power is equal to V squared over R. So, okay, the power of the lamp depending on the voltage across the cell. So that is why no matter how much the variable resistor is being adjusted, the power across the lamp is still the same because it depends on the resistance of the lamp itself and it depends on the cell, the EMF of the cell. So I would say A is the answer. Number 34, the sum of electrical current into a point in a circuit is equal to the sum of the currents out of the point. This is definitely Kirchhoff's first law, and it is due to the conservation of charge A. Kirchhoff's second law is due to the conservation of energy. 35. A battery of the electromotive force 6 volt and negligible internal resistance is connected to 3 resistors as shown. The current in the battery is 0.12 ampere. What is the resistance R? I find the total resistance of the circuit first. So R total is equal to 6 V over I. I got 50 ohm. I know that these two resistors are connected in parallel, so I solve for this first. 1 over R total is equal to 1 over 60 plus 1 over R. And then, wow, okay, 1 over R total is equal to R plus 1 divided by, okay, this one times 60, this one times 60, this one times R, this times R. So plus 60 divided by 60R. R total would be 60R divided by R plus 60. Now, this is in series with the 30 ohm. So the resistance, okay, the total resistance of the circuit is equal to 30 ohm plus 60R over R plus 60, which is equal to 50 ohm. 60R over R plus 60 is equal to 50 minus 30, you get 20 ohm. Cross multiply 20R plus 1200, 1200 is equal to 60R. So 40R is equal to 1200. R is equal to 1200 divided by 40 and I got 30 ohm. So the answer is B. Number 36, a potentiometer circuit may be used to determine the unknown electromotive force, EMF E, of a cell. The circuit diagrams include a battery of known EMF and negligible internal resistance, a uniform resistance wire, XY, and a galvanometer. Which circuit shows a suitable arrangement for determining E? Okay, I want you to see this. First of all, galvanometer must be connected to E. So A cannot be the answer. C cannot be the answer. And then the second thing is that when this is positive, this is called driver cell. Driver cell positive must meet the positive of E. Right? So that is why B is the answer. Number 37, a uranium atom with a charge of positive 2e has a nucleon number of 235 and a proton number of 92. E is the elementary charge. What is the total number of protons, neutrons, and electrons in this charged atom? So I'm going to write uranium first. Okay, nucleon number 235, proton number 92, neutron number would be 143. And then total number of proton plus neutron plus electron. So 92 plus 142, and then positively charged by 2e, extra 2 proton. That also means that electron is led by 2, so 90. Now you add out all, you will get 325. The answer is B. 38. A nucleus W of radioactive isotope emits a beta negative particle and form nucleus X. Okay, I'm going to write down first. W, A, Z emits beta and I form X, right? X, this is A, this is Z plus 1. And then X emits X. X is A, Z plus 1 emits alpha for 2He, and I got A minus 4, Z plus 1 minus 2, Z minus 1. That is Y. And then nucleus Y, A minus 4, Z minus 1, Y emits a beta, 0, negative 1 beta to form Z. Z is A minus 4. Z minus 1 plus 1 is Z. This is Z. Which statement about Z is correct? Right. Z is a nucleus of different element from W, has a higher nucleon number. Actually it's lesser nucleon number. And BZ is a nucleus of a different element from W and has a lower nucleon number. This is true, but different element. It is the same element. Z is a nucleus of the same element, has a higher nucleon number, no, lesser. So D is the answer. Number 39, which particle is not a lepton? Electron, yes. Neutrino, yes. Positron, yes. Neutron is not a lepton because neutron consists of 3 quarks. Up, down, down quarks. Number 14, how many flavors or types of anti-quark are there? So you have anti-up, anti-down, anti-strain, anti-charm, anti-bottom, anti-top. 1, 2, 3, 4, 5, 6, altogether 6. So that is the end of our discussion, right? So thank you very much for watching and I see you in my next video. Bye.